Will it sink or will it float? This is Miss Brown, Lesson 5, Video 5. The purpose of this investigation is hot water denser or less dense than room temperature water? Or is cold water dense or less dense than room temperature water? Think about it. Students are going to observe objects placed in water. Some will sink and some will float. If they float, they are less dense than water. However, if they sink, they are more dense than water. Density is a word we use to describe how much space an object takes up compared to the mass of the object. Things have different densities. In other words, a pound of one thing may be larger or smaller than a pound of something else. Which weighs more, a pound of feathers or a pound of nails? This is the perfect riddle for this lesson. Well, if you guessed a pound of nails, you were wrong. Actually, they weigh the same. A pound is a pound is a pound. It takes many, many, many feathers to make a pound, and it takes a tiny amount of nails to make a pound. The volume, how much space it takes up, of two different kind of tricks you, right? Imagine this. If you had to pick one thing to put in this empty box of crayons, or crayon box, could you put a pound of feathers in it? Or could you put a pound of nails in it? Think about it really hard. That's right. There's no way you could put enough feathers into that box to get a pound of it in there. However, it would only take a small amount of nails to weigh a pound. So you could get a pound of nails in that crayon box. Another way to think about it is how squeezed together something is. If it's squeezed together tightly, like a nail, it's very dense. But on the other hand, if there's lots of space in it, then it's less dense. Let's think about temperature. Do you think hot or cold water is less dense? Students will observe what happens when a bottle of hot water is lowered into a cup of room temperature water. And then you're going to observe what happens to a bottle of cold water when it's lowered into room temperature water. The hot water will be colored red, and the cold water will be colored blue. The results of this simple test will let us know which will be more dense or less dense. Be sure to record your results on the paper in the supply bag. It looks like this: sinking and floating water. You're going to draw a picture, or you can explain in writing. For the older students, of course, you know Miss Brown likes to see you writing, so write your results. What you'll need: you're going to need 2 large clear plastic cups of water, room temperature. You'll need 2 small bottles, one filled with hot water, one filled with cold water, one hot water colored red and the cold water colored blue, or you can choose any other 2 colors. You're going to need 2 craft sticks, 2 rubber bands, 2 clothespins, and then you'll need that food coloring. Hello, welcome back. Today we're going to be talking about something that's kind of hard to explain to younger children, but I think you'll get it. We're going to be talking about density. Now, density is a lot different than weight. When you kind of think about density, the first thing that pops into my mind is weight. Well, weight really has nothing to do with it because, well, density is about how tight something is made together. For example, this is a piece of styrofoam. You find styrofoam all over the place. Um, when they made the styrofoam, it was made that has lots of air in between the molecules. And something about the same size as this would be this rock. I found it in my yard. Now, even though they're the same size, practically the same size, one is more dense than the other. And you'll see that in just a minute when I put it into this bowl of water. One of them is going to sink and one of them is going to float. Can you guess which one? Well, let's get started. I'm going to put several different things in this cup of water, and you will see, you'll maybe start to understand what density is compared to how much it weighs. Well, let's start with this piece of string. Now, the string is really lightweight. Let's see if it's dense or not dense. So this piece of string is floating. It did not sink. So it's not very dense. Let's try this piece of decorative stone. What do you think that's going to do? Is it going to sink or is it going to float? Let's see. So it's very dense because it sank to the bottom. Let's try this ring. What do you think? It's a pretty little ring. Is it going to float? It's got a dolphin on it. Or is it going to float? Is it dense or not very dense? Well, it sank to the bottom, so that means it's very dense. Let's try this rubber band. Rubber band floated, so it's not very dense at all. It's less dense than the ring. Now, let's try this dice. Very dense. It sank to the bottom. Now, these two things are about the same size. One's going to maybe float, maybe one's going to sink. Let's see which one. It's a piece of styrofoam. It did not go to the bottom. It's floating on the top of the water, so it's not very dense at all. However, this rock, about the same size, when I put it in, went all the way to the bottom. So it's very dense. It's tightly squeezed together compared to this piece of styrofoam, which it's the same size, but it's got like space in it, like air in it, kind of. So maybe you'll understand density a little bit more. Now, our question today is, which is more dense, hot water or cold water? So for this activity, you're going to need, first of all, your data sheet. You'll find it in your supply packet, sinking and floating water. You're also going to need 2 large clear cups. You're going to need, you'll find all these materials in your supply packet. I made sure everybody had one. You're also going to need this little vial. It's called a vial. It's a 7-gram vial. You're going to need a rubber band. Actually, 2 rubber bands, 2 craft sticks. You're going to need 2 clothespins. And of course, 2 cups of water. Now, I did not put the food coloring in your supply packet because that would be a mess, of course. But it's just right now after Easter. I'm sure your parents have some still left over from coloring Easter eggs. So you'll also need 2 different colors of food coloring. It doesn't have to be red, doesn't have to be blue, just 2 different colors. So I choose red. I'm going to use red for the hot water, and I'm going to use blue for the cold water. So we're going to start out with 2 cups of room temperature water. Now, our question is, which is more dense, hot water or cold water? Well, what's your guess? Well, we're going to find out. So we're going to, first of all, fill our cups with water. And then let's start with, let's do hot water first. Now, make sure that you have somebody older help you with this hot water, because I don't want anybody to get burned. But it doesn't have to be boiling hot, really hot water, but it has to be just hotter than room temperature. So we'll start out with that. And then we're going to need some cold water. And what I did was just got a cup of ice and poured some water in it and then let it sit for a minute, and then wham, you got cold, ice cold water. So, now this is what's going to happen. When I put these vials in these cups of water, one of them is going to kind of stay in the cup, and one is just going to rise and go everywhere. The one that stays in the cup is going to be less dense. Just like when we were floating or sinking things in this big cup. If it was less dense, it stayed on the top of the water. If it was real dense, then it sank to the bottom. So are you ready? Let's do the cold water first. So, this is the cold water. It's ice cold water. This is room temperature water. Is cold water more or less dense than room temperature water? So we're going to just sink it in there. Kind of don't splash it everywhere, because then you have like a mixture. We'll just kind of clip it in there so it won't kind of go anywhere. Let it sit for a second. And then we'll take the hot water. Is it more or less dense than room temperature water? So we'll observe it just for a second. Kind of looks like it might be doing the same thing, but I bet you it's not. I bet you it's going to be different. Now, if you look through the side, just bend down and kind of look through your clear glass, you will see that the hot water rose to the top. And you will see that the cold water, if you kind of look through the cup, you will see that inside that vial that we sank, it is real dark blue there. So it kind of stayed in the vial. So it did not rise to the top. So hot water, after doing this experiment, hot water is more dense. I'm sorry. Hot water is less dense than room temperature water. Just like the styrofoam was less dense than the rock. And the cold water is more dense, just like the rock. I hope that explains it a little bit better. Now you know that hot water and cold water has different densities. One is less dense than the other. Have a great day. This is what we learned. Warm water is less dense than room temperature water. Cold water is more dense than room temperature water. Cold water is less dense than warm water. And a material that floats is less dense than water, but a material that sinks is denser than water. Add these words to your word wall. Sink, denser, float, less dense. Warm water is less dense than room temperature water, and cold water is denser than hot water.
What the? The Daily Bugle says the government wants everyone to stay home due to this coronavirus outbreak? I know what I have to do. Gotta stay inside and find things to do. Hey, T'Challa. I was just checking to make sure you and the Kingdom of Wakanda were staying safe during this whole COVID-19 thing. You are? That's fantastic news. Stay safe, brother.